This is part 7 in this YouTube series where I am working to convert this RPG game into this pseudo 3D racing game. In the last episode, I added the beginnings of a UI to the game. This included text menus and navigation with sound effects and actions for each menu item. The focus of this episode will be adding flair and polish to the title screen and game over screen. These finishing touches will make the game feel more complete and engaging. The title screen will have a color-changing background and random star shapes that move around the screen. The game over screen will have a melting effect for the text and a simple animation for the game over message. To begin, I am going to add a new linear interpolation function to the game scene. Linear interpolation, or LIRP, is a technique used to smoothly transition between two values over time. It is commonly used in game development for things like movement, animations, color transitions, and physics. So this function I am making will be reusable. It is fairly short. It takes a start value, an end value, and a factor. You can read more about the formula online, but it is simply a way to calculate a value between 2 points based on the factor. Since I am using this to change colors, I am making a helper function that takes 2 colors and a factor. Then, I just call my LIRP function with the red, green, and blue components of the colors. This will allow me to smoothly transition between 2 colors over time, and is specific to LIRPing colors. Next, I will create a function to calculate the background color for the title screen based on the elapsed time. This function will set 3 colors I want to transition between: blue, purple, and pink. I set a duration for the transition, which is how long it will take to go from one color to the next. I also calculate the total duration. Then I calculate the current color and the next color based on the elapsed time, chosen as an index from the color slice. Then I need to calculate the factor, which is the percentage of the elapsed time compared to the total duration. After I pass all those values into my LIRP color function, I get the current color based on the elapsed time. After I call this function in my draw method, I can use it to change the background color of the title screen. The transition is a bit too fast, so I can adjust the factor to slow it down. My scene uses this elapsed time variable to keep track of how long the scene has been active, and there are other ways to do this, but this is a simple way to adjust the speed of the transition. This gives the title screen a nice, smooth color changing effect, but I will take it one step further by adding some random star shapes that move around the screen. I am going to add a star struct to represent these stars, which has a position, velocity, shape, and color. And in my game, I will create a slice of stars to hold them, which will be initialized by a new function. I will create a new title scene stars.go file to hold this logic. This function will create a set quantity of stars within a given set of dimensions. I first make a slice of stars and a list of shapes. Then, I loop through the number of stars I want to create. For each iteration, I will create a new star. I generate random positions for the stars within the screen dimensions. I also generate a random velocity for each star, which will be a value between -3 and 3. I randomly choose a shape from the list of shapes, which can be a plus or a square. I also choose a random color for the star. Finally, I add the star to the slice of stars and return it. That generates the stars for my title screen, but I also need a method to draw them. I set a static size for the stars, which I can adjust later if needed. Then I do a simple switch statement depending on the shape of the star. For the plus shape, I draw 2 lines that cross each other using the vector package. I use the vector package to draw a filled rectangle for the square shape. Then, in my scene's draw method, I loop through each star and call its draw method. If I run the game now, I can see the stars being drawn on the title screen. You will notice that the stars are not moving yet, so I need to add some logic to update their positions. To make the stars move, I create an update method for the star, which looks similar to other update methods in the game. I need to increment the x and y positions of each star by its velocity. I also add a mechanism to wrap the stars around the screen when they go off the edge, which gives it a continuous movement effect. Similar to the draw method, I loop through each star in the scene's update method and call the stars update method. Running the game now shows the stars moving around the screen. The stars are moving a little too fast, so one way to fix that is to adjust the velocity of the stars when they are initialized. Right now, I set the velocity to a random value between -3 and 3, but I can change that to a smaller range. After a little trial and error, I find a range that looks calming and smooth. With the title screen done, I also want a little bit of polish for the game over screen. Something to make it feel like the game is ending instead of just static text. I am going to add a melting effect to the game over text. The start of this function will look similar to the freeze frame effect I made for the pause screen. I get the width and height of the screen, then create a copy of the image. Next, I loop and slice the image into vertical strips, which I defined as an image.rect. I use Ebitengine.subimage, and then I translate it by the offset. Finally, I draw it to the screen. The game over scene is not yet incrementing the elapsed time variable, so I will add that to the update method. I just need to call this method from my game's draw method to see how it looks. Now the game over screen feels more dynamic and seems to be working well. You can also change the visual effect by adjusting the slice width, which determines how many strips are drawn. You could also adjust the elapsed time variable to change the speed of the melting effect. This effect could be extended to simulate blood running down the screen, or you could change the direction the strips go. It just depends on the effect you want for your game. The simple melt effect works here and gives the game over screen a sense of finality. The slower melt speed allows the player to think about their mistakes and reflect on the game so they can do better next time. In the next episode, I will start removing the RPG elements, start drawing the sky and ground for the racing game,